Okay, we have our stuntman driving a car at a speed of 20 meters per second off a 30-meter high cliff. The road leading to the cliff is inclined upwards at an angle of 20 degrees. How far from the base of the cliff does the car land, and what is the car's impact speed? So, a little sketch. Our car driving up this incline, so the cliff isn't horizontal. It's angled at 20 degrees above the horizontal, so the car is traveling 20 meters per second at an angle of 20 degrees above the horizontal as it comes off the cliff. The path the car will take, because it has some upward motion, it will continue upwards a little bit before it starts falling towards the ground. So its motion will be parabolic. It is not a straight line, so we have to break our problem into x and y components. Our velocity, our initial velocity, has an x component and it has a y component. The x component, since it's adjacent to the 20 degrees, will be 20 meters per second times the cosine of 20. The y component will be 20 meters per second sine of 20, since it's opposite. Since we're still ignoring drag, the acceleration will be constant. So we can use our kinematic equations. So if we write down what we know, for both x and y, bless you. Where would you like to put the origin?
0. At the top where it leaves.
At the top where it leaves? Okay. If we do that, then both the initial x and y will be 0. We're looking for the final x. What about the final y?
Negative 30.
Negative 30 meters. Okay, the initial velocity in the x direction is 20 meters per second cosine 20, which is 18.79 meters per second. The initial y velocity is 20 meters sine 20, which is 6.84 meters per second. Since we're ignoring drag and there's nothing propelling the car horizontally, it's not wearing a rocket pack or anything like that. So there's no acceleration in the x direction. The acceleration in the y direction will be that of gravity, so it's downwards, so negative 9.8 meters per second squared. So that's all the information we know. By the way, why don't we say Vy final is 0?
Because the instant before it hits the ground, it's the velocity you want.
Right, this needs to be the instant before it hits the ground, because that's when the acceleration is still 9.8. If we talk about when the velocity in the y direction is 0, a whole different acceleration caused it to stop. So we wouldn't be able to use the kinematic equations if we want to say Vy final is 0. So we don't know what it is. We do actually happen to know the final velocity in the x direction, though. Right. Same as the initial. Because there's no acceleration in the x direction. If there's no acceleration in the x direction, then the velocity in the x direction cannot change. Okay, so how far from the base of the cliff does the car land? To find that, initial x is 0, acceleration in the x direction is 0. So our final position will be our initial velocity, which we know, times the time. We need to figure out the time in order to figure out how far it goes. Well, if we want to find time, we're going to need to use this y information. So we can use the same equation, but for y, we're going to have a quadratic equation That one's 0. So just plugging in the values I know. So this means we have 4.9, negative 4.9 t squared plus 6.84 t plus 30 equals 0. Quadratic equation. My calculator does it for me, so I let it. The positive value for time that it gives me is 3.27 seconds. So that's our time. That's how long the car will be in the air. By the way, if you don't know how your calculator does the quadratic equation, or if it doesn't do the quadratic equation, you can take a couple different steps. You can find the final y velocity first. We know y naught is 0. So the final y velocity will be plus or minus the square root. Initial velocity was 6.84 meters per second. Final y is negative 30. This caught a lot of people. The number I get is 25.2. But if I leave it the way it is right now, what does that imply?
Going up.
Going up. My car, right before it hits the ground, is not headed upwards. You have to get the correct sign when you use this equation. So when you have Vy, you can use our second equation with velocity and acceleration to find time as well. So if you don't want to do the quadratic formula, find the final velocity in the y direction first, then use this equation to find time. Either way, you get the same answer, which you should, since it's the same problem. Okay, so now that we have the time, we know the initial velocity. So our final position will be 61 meters. As a reminder to all of you, please keep a few decimal places as you go through the problems. Don't round early on. Get those off your answers. So keep a few decimal places as you go through. So your final position, how far it lands from the base of the cliff, is 61 meters. Questions on getting that part? Okay. The second question, what is the car's impact speed? That means how fast is the car going when it crashes into the ground? Well, it's traveling downwards at 25.2 meters per second, but it's also traveling horizontally at 18.79 meters per second. Impact speed means totally, overall, how fast is it going? Doesn't mean in one direction versus another. Overall, how fast is the car going? So that means we need to say here 18.79 meters per second in the x direction, 25.2 meters per second in the y direction. The overall speed is the hypotenuse. So 18.79 squared plus 25.2 squared, square root, 31.4 meters per second. Now remember, speed is just a scalar. It's simply how fast. If I wanted the angle as well, how would I have had to word the problem? Not how do I find it, how would I word the problem? What's the impact velocity? Exactly right. So if it had asked for the impact velocity, you would need to know how fast and what angle. But speed is just how fast. So it's only the magnitude only. So all we need is the 31.4.